this computer. Good deal. Um, so thanks for joining us this morning. I know we're a week out of phase with, kind of skipping the Easter weekend. Um, and lots has been happening. So let me just start by sharing our agenda with you guys. Um, I pushed a couple more things onto the agenda. Um, just this morning as I became kind of more organized and maybe less generic than usual. Um, so, this past year we've gotten a couple of new grants, largely around the youth development side. Kind of um, just getting funding for more students to join the project, college students and high school students. And that generated some recent press coverage. So there was a lovely piece on Channel 13 in Albuquerque last week. So there's a link to that video here on TV, and then there was a lovely piece by the health writer for the Santa Fe New Mexican. She interviewed our nursing student Emma, who's here with us today, and um, and she sent a photographer who was just like so thrilled to be around a bunch of young people like making stuff, and he took some beautiful photographs. So I might just flash that at you guys just real quickly. Um, especially because a lot of you that are at some distance may not get a chance to meet the students, right, or to see their level of concentration. Um, and so this is kind of our workshop. Camilla and Luis are some of the most focused of our students. And they're just sophomores and juniors. Sheila's a freshman. Miss Janice is the co-teacher that I work with. Juan Andres is on his way to New Mexico Tech as a senior. Um, and couple of the photos, one of our participants, Jim Holden, um, provided us with resources to purchase an electroencephalogram kind of hairnet. So this is a college student, Nick Lopez, fitting Levi with electrodes to measure brain waves. And right now we're able to distinguish between vibration on and vibration off. So we're able to see the manifestation, while the glove is on of what's at least that there's something happening in cortex, right? The whole idea is to understand how the glove, if indeed it does, kind of rewire motor cortex over time, rewire in the good sense, right? Of weakening connections, that were in the way of voice or motor or intention. And these are a pair of sisters. So Alicia has been with us for quite a long time, and she brought her sister Amelia to the project this past semester. And we're kind of taking a look at a new prototype for how things might be attached to the finger. So there's constant kind of redesign. Alicia's with us today as well. She's responsible for kind of getting our Facebook discussion group up and going. Amelia's responsible for creating the logo that we now have of these interlocking hands forming a heart. Um, and then finally, yeah, some measure of the photographer's fascination with the project. Here he is over the shoulder of Luis. And while Luis is through a magnifying glass soldering the computer onto the printed circuit board. So just really, I'm really super proud of the kids, right? And being able to like share their work with a much broader community now this is like one of the flagship papers of our small state of New Mexico. Um, um, Watching videos inside of videos in Zoom is not a lovely activity, but I hope you guys can take a look at the 2.5 minute piece. The Alicia is very eloquent about what it means for her to be part of the project, and also Isaac Ruiz, one of the high school students, is also quite candid in front of the camera. I would not have been so eloquent at 16 years old being interviewed by a reporter. So that's recent activity. Some other kind of ongoing things that are, I think, a growing thrust of what we're doing. We're now getting on the order of kind of one new glove request per day, and we're able to keep up with that level of demand. Um, and anything more is probably also a little bit possible, but rather than increasing our output, I'd rather increase the ability for other schools to grow workshops like ours, right? And um, so we've got funding from the Encantado Foundation to train a number of MESA teachers at Santa Fe Community College. That's an ongoing training. That's kind of 5 Saturdays over 4 months. And I guess the pace of that is good. It gives us a chance to really develop training materials, but it doesn't really, meet the urgency of like really getting things up and running. Except for one of the teachers is really on fire about this. But rather than doing kind of 5 days over 5 months, in the first week of June, we're going to do 4 8-hour days with 10 teachers in Albuquerque through funding from the New Mexico STEM Innovation Hub. And so that'll then be 15 teachers that have been kind of touched by what we're doing. And so I think there's a good chance that a few of them will actually, um, be able to follow through with that kind of our continued guidance. Um, and so if you are kind of New Mexico based, I mean, this if you want to share this information, with teachers in your school district or neighborhoods or even administrators, I'd like to kind of get the word out. Um, we've got so I have not really been monitoring the Facebook and Instagram. I'm hoping those things can be kind of user driven. But if you've got any feedback for Alicia and I, um, I'd be happy to receive that, as well as if this has become if it's useful, if it's a hindrance, if it's yeah, I'm just interested in whether it's been helpful to have a discussion group. Um, I should probably put links there, but there are links, right? Almost all these things are linked from our one main webpage.
I'm one of the people that was hoping we'd get something like the Facebook, and I'm happy it's up and running. I have gotten some answers to questions I had uh, weeks ago, and happy with that. And I have checked in on the Facebook page several times since, um, and I didn't notice a lot of
Activity.
comments. I'm not very adept with the whole Facebook thing, but I think it's a good thing, and I hope it continues. And maybe as we get more glove users, there'll be more people that will perhaps. I'm not sure if you guys have a mailing list or how you communicate with all the people who have ever bought a pair of gloves, but maybe not. Does everybody know that the Facebook page exists?
That's a good question. So I do have I mean, I do, we have a mailing list of everyone that's received a glove, and um, so each of these meetings, Julie, that we're having right now, I basically spam our whole user list, telling them that this is happening, and to share with them the agenda. Um, and then we've got a YouTube channel of recordings of all of these. So how to exactly get the word out best, um, yeah, it's not so clear. Um, but I'm trying to inform people. Also, there's the ability people can unsubscribe from that list if they're receiving too many emails from me.
Yeah, well, no, but I mean, from what you're saying, presumably, if people read what you're sending out, everybody knows about the face then.
That's the hope, yeah. But they'd have to click on the agenda kind of thing to see that. But yeah. Um, or they have to visit the front page of the web page, which again I know is still a mystery for a number of folks who aren't really connected to the interwebs. Um, Good morning, Betsy. Welcome.
Hi.
Um, so we've just worked through kind of the first four kind of quick menu items on the agenda, um, and I'm now interested in kind of getting any updates of uses from you all about kind of your experience with with the glove or questions. Um, we are very close to finishing the iPhone version of the app. I can tell you, so I know that a number of people are hanging on that. Um, and in addition, once that app goes out, there'll even be kind of maybe hidden improvements, on even the Android version of that. And so we've got feedback from a couple of of local folks as well as just kind of using the app ourselves as we're wearing the glove. And so it's quite possible that by next week, but I'd say within 2 or 3 weeks, we'll be able to launch the iPhone one. That again, the launch of any iPhone thing is a little bit it's staged because of the kind of the much more rigorous vetting procedure that iPhones have. Um, and so it will first go out as a test flight, and so I could add test users to this, and then once we collect enough data through test flight, then Apple allows us to put it on the App Store. Um, but the test flight is totally free, right? Well, I mean, everything will be totally free. But it's just kind of one more step that you have to install some test flight, software on your phone to be able to test out, a new, well, because not quite new. It's a what I hope to be a new app for the App Store.
Very exciting. I am an Android user myself.
Gotcha, gotcha. Yeah, so on the Android side, we've added, so as I prepare for clinical trials they're going to start in Texas in this year. I mean, one of the issues is just trying to understand adherence, right? So we can't really talk about effectiveness until we really know, how many sessions per day someone's wearing the glove and how long each of those sessions is. So the app will now be able to help keep track of the number of sessions and the duration of each session, which should be less of a burden than on the research subject who's like wearing this thing. It's not. Hopefully, the glove is so comfortable people don't even know how long they have it on. So we're able to track those things automatically. Um,
Sounds great.
um, we
I'm
continue to also innovate kind of on a number of levels for the design of the glove, and I was able in the past couple of weeks to meet with a glove team at Rice that's also that's been kind of working in parallel. They've got a very different design. And we talked about, they're interested in coming to one of our Sunday sessions and we can have a little show and tell on kind of both sides about where we're at in our glove designs. So I'm going to try to interest them in coming on the 26th for our next meeting, but I'll keep you posted.
fantastic.
Um,
I have referred several people um, to your site to check out the glove. Two of them have had ordered the beach band
uh-huh.
going off during a meeting, and it sounded really kind of very distracting. They were neither of them satisfied with it,
Gotcha. Hmm.
unfortunately.
Yeah.
Without the magic algorithm, I guess the
Yeah.
vibration wasn't enough.
Yeah, it seems to be better as kind of a metronome or a pace keeper to maybe keep you in step or in rhythm or something. Um, but you're not. Yeah, I'm curious, but it is a very different device. Um, we might get to a little bit about its efficacy when we talk about the neuroscience presentation, in the next agenda item. Um, but I believe that's all the kind of big news that I have. Um, we're constantly embarking on writing more grant proposals to fund more students and to fund other directions. Uh, I have this research student working on the electroencephalogram measurements and trying to detect finger patterns in cortex. And I have another pair of research students that are still working on the wireless electro EMG sensor. So it would be kind of an armband that would go around your bicep and make electrical measurements of muscle contractions. Those have been found to be quite, much more trustworthy signals for measuring Parkinson's than just gait or voice. Because they're closer to the real thing. I mean, they're getting muscle signals. Um, and we've got software that also integrates that with our app. These are all kind of under development things, um, but that would be kind of an add-on um, to what the glove is doing. But since it's wireless, it can communicate with the glove. And then again, the whole idea is the more data that we can gather from at-home non-invasive testing, then the better we can tune the timing pattern of your stimulus to your own symptoms. Um,
Mhm.
I have a PhD student at UNM Computer Science who's uh, who's now embarking on a separate clinical trial, kind of without the glove, but we're just taking voice data and gait data, very similar to the Android data that you've been using, Julie, and other folks, and trying to build, a machine learning algorithm to see if we can, first of all, kind of diagnose, Parkinson's, but then also watch its progress over time, just with this non-invasive at-home testing. Um, um, On the health assessment side, we're, recruiting more nursing students and more nursing faculty into helping us kind of hopefully in the coming year reach in kind of a broader class of high school and college students. So right now we've got a lot of early adopter kind of STEM and engineering focused kids. Um, but there's lots of kids interested in health professions that also I think they kind of see the focus and technique and computer skills that we're developing, and they say that's kind of not for them. Um, so we're pushing into more tighter collaboration with nursing faculty at my college to bring in health assessment and health professions is kind of a gateway into the glove project. Um, and then also just to involve more of those kids in kind of just the caring aspects of Parkinson's rather than the technical aspects of Parkinson's. Um, we did have one glove participant come in on, oh, I forget if he was there on Tuesday or Wednesday, but Jim Holden is kind of doing cross country trips. Um, he's also pretty destructive of his gloves. Came in to pick up a new pair, um, and uh, and he got a hug from one of our glove makers. Right, he got to spend an hour with these kids. Um, Another gentleman from Santa Fe was there yesterday, getting to interact with kids making the gloves. Um, so having them connect with participants and kind of understanding the nature of the disease and the hope that the glove possibly brings. Um, that's a powerful side that's kind of it needs more kind of intentional programming to kind of connect these kids to home health care, to elder care. Espanola is a place where 60% of our students don't have parents at home. They're raised by grandparents. Um, So I would love to kind of flip that script and have more of our kids actually, caring for elders rather than just being, receiving care from elders. Um, yeah, so if it's okay then with you guys, I'd like to kind of continue in with our what I think to be a super, super exciting paper on Parkinson's disease as a SCAN disorder. SCAN here stands for Somatic Cognitive Action Network. It's kind of a word salad. It's not really clear what that means until we take a look at pictures. But there's two very, very important figures in the paper that I wanted to share with you all. Um, and it's also somewhat, I mean, it's still a little bit. These are kind of quite recent papers, fresh off the press, but they're really they are super ambitious and going after like the Holy Grail in the sense of, what is really the circuit of Parkinson's? There seem to be symptoms that are brain wide, and the brain has 80 billion neurons. So it's just that haystack is just way too complicated. Um, but they're now bringing so many groups and so many tools to the table, that I think they've discovered something new and fundamental about Parkinson's, um, about the circuit. And the reason I think it's fundamental is because this new knowledge they immediately put into practice. So they found new places, for treatment, and they actually then brought treatment to those places in the brain and got significantly better, results than poking around in the old places. So let's, uh, with your permission, I'm gonna uh, take a peek into this paper. Yeah, so let me kind of go back to the beginning. Um, and so it's a paper in Nature, and Nature is the premier science journal. Um, and for non-scientists, it's somewhat it's a the good side is that Nature papers are typically brief. The downside is they're brief because they're extremely terse. Yeah, that they are written largely for fellow experts in the field. And so, but there's been greater focus on kind of on being able to visualize your results, to be able to share with a more general audience. Um, and so, so the first picture, and again, I may have flashed this previously, but there is a lot going on in this figure, right? And so there's part A, part B, and part C. Um, and so let me. I think figure C has the greatest, kind of ability to connect with previous things we've been thinking about. So we for months now, I've been showing you pictures of kind of pieces of motor cortex. And so these are motor neurons, which in some, in the crudest sense, a firing of a motor neuron here in the foot area would then, would innervate and change, contract or retract a foot muscle, or here a hand muscle, or here a mouth muscle. But of course, as we learned, it's not just a one-way street. It's not just a motor neuron telling the foot what to do. There is this very, very rich and beautiful loop from cortex to thalamus to basal ganglia. So these three structures, or four structures, five, are these are the small pieces here, subcortex below the bark of the brain. And this large piece here is the thalamus. So these are now expanded here so we can take a better look at them. But we spent a lot of time trying to understand how information goes from cortex to the putamen, that's the input structure to the basal ganglia, and from the putamen to the globus pallidus, which has two pieces, an externus and an internus nuclei. There's also a pathway through the subthalamic nucleus. And then we spent a lot of time in the substantia nigra. So this is this is the epicenter of Parkinson's. These,
We
this
just
is
listening. I'm not on Zoom.
this is the place where dopamine neurons live, and this is the place where dopamine neurons are then destroyed by Parkinson's. And so that the role of that nuclei is super, super important in understanding. But you see, it's quite a
I lost
complex
it
loop.
on there.
Um,
I lost it on the thing.
so let me. Can I help? Can help somebody? Was there a question or someone's on the line? I think that's Mary's muted now. Good deal. And so there's in this paper, there's nothing new about this pathway, friends. This loop remains central, and to see kind of how central it is. And we've also talked about, neurons that excite each other, neurons that inhibit each other. And then where are the places that are targets for deep brain stimulation? And so hopefully I'm magnified enough. I can go a little bit better here. Um, Hopefully that's a little bit easier to see. And so right now, the places that have been kind of approved for deep brain stimulation are one of the nuclei inside the thalamus, the subthalamic nucleus, as well as the globus pallidus internus. And so, depending upon the symptoms present in the Parkinsonian patient, the neurologist and neurosurgeon choose, kind of different targets for where to place the electrodes. Um, and you see, they are neighboring regions, but still, a centimeter in cortex is a long way around, a long way from each other. And so these are really, really well studied pathways, and we've been studying these pathways because, in some sense, what's what's believed, right, is that when the motor cortex makes, a motor pattern or a desire to move certain muscles, that basically that kind of gets filtered by the basal ganglia to kind of step on or inhibit all the other kind of competing muscles, right? We want to be moving in some fluid fashion. So we have to permit the pathway for one set of motors to move, muscles to move, while we're depressing things that could antagonize that. And it's that kind of too much of a brake being put on slows down motion or freezes motion. That's kind of one high level um, explanation for what the basal ganglia is doing in healthy individuals as well as in the Parkinsonian brain. And what's new about the paper that we're looking at is that the old model of motor cortex basically just had the whole human body laid out along the bark, right? And so again, if this is the right motor cortex, it would be affecting things on the left side of the body, yada yada yada, for opposite for the left side. Um, and so what's been discovered is that between the foot and the hand, there is a region of cortex which is not really loyal to any particular part of the body. It's more integrative. It more kind of combines um, information from different parts of the body. So according to the last paper we looked at, it looks at the whole puppet. It looks at the whole manifestation of kind of motor control. So in between foot and hand, there is a piece of the SCAN network, the somatic cognitive action network. Likewise, between the hand and the mouth is another fold of SCAN, and then even below the mouth is another fold of SCAN. Um, and so, I mean, it's been known for a long, long time that this kind of cartoon of the body laid out in the cortex, that it was not a fully fleshed out model. It's difficult to actually get in and probe all of these places over time. And there were some places that did not seem to be, you could more or less shock this part of the brain, and the foot wouldn't move, the hand wouldn't move, the mouth wouldn't move, and say, well, maybe we didn't have enough current, or maybe this is a strange individual, yada yada yada. And so, only with now more advanced neuroimaging techniques have we been able to kind of flesh out what's going on in these kind of these nodes in between effector regions. And then the surprise for Parkinson's is that these scan pieces of the cortex are more heavily connected to the basal ganglia than the effector parts of cortex, right? And so we think, that so the hand is shaking, there's tremor, right? The 200 mouth muscles are not working in coordination, right? And we tend to focus in on the mouth or the hand or the foot, and we kind of are missing these pieces of the network. And the price of that is kind of discussed in these bar graphs. Okay. And so in each case, we can just take a look at one, for example. Let's look at the putamen, for example, right? The putamen is the input structure to the basal ganglia, kind of the beginning of this thalamocortical loop going through basal ganglia. And we through really high resolution neuroimaging, they find that the putamen gets more input from the scan part of motor cortex than it does from the effector part of motor cortex. So again, these are motor neurons connected to that will go directly to the hand, the mouth, and the foot, but also, through the thalamocortical loop. There's more connections to the internodes, the things between effectors, than there are the effectors. And the the three asterisks mean these. This is not just uh, this is not by chance. These are statistically significant findings that the putamen gets better connected to scan than effector. The globus pallidus, externus, and internus are better connected to scan than to effector muscles. The ventral intermediate nucleus of the thalamus and the centromedial nucleus of the thalamus are both more highly connected to scan than effector. The same with subthalamic nucleus. And for substantia nigra, there's even a reverse correlation. There's no connection to effector muscles, where there is substantive connection to what's going on in these nodes, right? And um, so hopefully this is old information that you're comfortable with that I'm sharing here, and then new information here, what's happening in cortex. And it's not just that there are these, interesting, little bulges in cortex. It's that they're connected to the disease center of Parkinson's more robustly than the motor areas themselves are. Um, and there's a kind of um, another way to look at that. Maybe this is a little bit more technical, um, and it's kind of explained kind of fairly well in the figure caption. So I might just kind of skip this stuff for now. Um, but in some sense, we're looking at where these nodes are. So these are scan regions, these three colored regions on both sides of the brain. Um, and then these are meant to be kind of the subcortical regions down here in basal ganglia and thalamus. So these pictures are kind of showing the same thing we're seeing here, only this is kind of averaged over dozens of brains. And and then I guess the key thing then to understand with Parkinson's is that um, the greater connection of kind of scan to basal ganglia is true in all brains, but it's even especially more true in the Parkinsonian brain. So they call this kind of a hyperconnectivity. So there's actually it's thought to be that there are too many connections between scan and basal ganglia. And so this then is a cause for kind of intervention. How then do we kind of lower that connectivity? So that's going to be, let me move into that next picture. Um, and so we see um, these are averages over six Parkinsonian brains, um, kind of the left and right hemispheres, and these are healthy control individuals. And and what we see, try to get a little bit more, sorry, kind of zooming in. Hopefully it's a little bit easier to see. So we've got these purple outlines of these three scan nodes in cortex, and their correlation with what's going on in subcortex. So what you're seeing down here is basal ganglia business, and up here is motor cortex. And we're looking at kind of coincident activity, which tells us, that these regions are talking to each other. Um, and I guess if you care to kind of piece this out, they're connected to each other through a technique called resting state functional connectivity. So these are brains that are in resting state. I mean, so you're alive and functioning, but they're not undergoing any particular task. And yet we're seeing kind of coincident brain activity in these regions, coincident way above chance. I mean, the brain is electric, and those 80 billion cells are going all the time. So it takes a lot of signal processing power to really see which parts of the brain are kind of firing in coincidence. And so these in the Parkinsonian brain, we see coincident activity between the scan nodes and subcortex basal ganglia, where in healthy control individuals, there is some, but much less. And so that's the bar graph. So the kind of connectivity of scan to basal ganglia is increased in Parkinsonian patients as opposed to healthy controls. And so, with that insight of kind of finding out which network is hyperconnected, they're now going to they're going to look at three treatment modalities. And we've talked about deep brain stimulation before, um, and so I might just leave that for another time. But we've not talked about these two other modalities. Um, and so, the first one I want to talk about is transmagnetic stimulation. And so it's been approved in the research literature as a treatment for Parkinson's. It's not yet approved by the FDA. So this transmagnetic stimulation, largely just they hold a magnet over a part of the brain that introduces a magnetic field, which causes electrical activity in kind of targeted centers, targeted nuclei. Um, and this has not been an approved treatment for OCD and for depression, especially for drug-resistant versions of OCD and depression. And we'll take a picture of that. But what we're going to see is that the previous uses of transmagnetic stimulation for Parkinson's was targeting the hand or the mouth or the foot, targeting effector regions, right? Going after those motor centers that were basically not finding their way to muscle. Um, and in the current study, rather than putting transmagnetic stimulation over effector regions, they're putting them over scan regions and getting substantially better results. I find that very, very exciting. And as someone who still puzzles over the glove, I really have to wonder, and again, this is why I'm excited to do electroencephalogram studies. I'm quite interested in understanding, you know, if the glove is successfully rewiring cortex, is it really is it able to, through these sequences to get at scan, or is it just playing around in these effector regions? Before such papers, it wasn't really clear, what role these things were having. So, so I'd like to move and show you the transmagnetic stimulation data. Yeah. Um, and so let's take a look at transmagnetic stimulation targeting in Parkinson's. And so kind of the effector regions. So this is foot, hand, and mouth. This is part of motor cortex, and this is a magnetic coil dropped, right onto the scalp. We can read about that. There's some lovely information about that at the Michael J. Fox Foundation, as a promising technology, but still not yet approved, largely because they were kind of getting ambiguous results because they're still looking for kind of the best protocol. Um, how big a field to generate over the brain, and then exactly which places of the brain to target. So I think this paper will be a huge contribution to understanding how much field to use and where to put it. Okay. And so they're going to compare what happens when you stimulate magnetically. And this is non-invasive. This is waking. The only downside is you can't have any metal in the brain, things like that. Um, there's oftentimes a little bit of scalp irritation, a little bit of kind of tingling or feeling kind of thumping. But this is, I mean, compared to DBS, this is a walk in the park. Um, but yet still still undergoing research for finding, the best the best field and the best place to put it. So here we are, kind of with these stimulation sites, these red dots on the foot or on the hand, and then watching the Parkinsonian score as you do this, over repetitively, over days or weeks. So we're going to compare transmagnetic stimulation in the effector regions to transmagnetic stimulation in the scan nodes, right? And so can you see? So there's the first scan node, there's the second, and there's the third. So they're here in purple on the left brain. Um, and again, they've got 18 patients, and here they just shows the kind of intermediate, the kind of the middle scan node as their stimulation site. And what they find over 2 weeks, right, is that if they're if they're using transmagnetic stimulation over effector regions of motor cortex, they're getting a reduction in your type 3 motor score um, for the Movement Disorder Society. So these are the scores that your neurologist records to diagnose you as Parkinsonian and then your progress over time. So scores going down are good, right? Um, so change in score, so losing 5 to 6 points over 2 weeks. But more or less, we get double the effectiveness just by the slight movement of this is the same the same stimulus, the same field is moved down, a couple of inches on cortex, and getting kind of twice the impact. And so again, kind of averaging. These are still small numbers, about 36 patients. Um, so I find this extremely intriguing that this small change in a non-invasive stimulus that also makes me hopeful, right? That a small change in the stimulus we're delivering to the glove um, will be more effective on people once we kind of know how to tune that. Here they're tuning the stimulus because these patients have undergone careful fMRI studies, and we really know where their scan nodes are. Okay. Just like people undergoing deeper stimulation undergo lots and lots of brain mapping to find out exactly where those DBS targets are. And so there's one more class of yeah, again, a fairly short paper. There's one more class, and they don't have good pictures for that. So I'll go back and start kind of maybe just with the opening picture to show you. I can maybe get to it there, but it's a little bit too precise for us to see. So I'll come back to. So again, depending on the symptoms presented and the stage of the disease, we can do deep brain stimulation on these three nuclei, someplace in the thalamus, someplace in the globus pallidus internus, and someplace in the subthalamic nucleus. And the other experimental technology that they discuss is, now giving kind of a new target, is that they do kind of MRI guided focused ultrasound. And so rather than a magnetic field over cortex, they're delivering ultrasound at a deep brain target. And typically now they've identified this piece, this ventral intermediate nucleus of the thalamus, as a place for targeted ultrasonic stimulation. And then they show that target gives you better results than previous targets for that focused ultrasound. So where the magnetic stimulation just kind of activates cells to fire, the ultrasound actually makes lesions. So the ultrasound actually kills cells. So again, if you have a hyperconnected network, again, it's one way to treat that, right, is to break connections by literally ablating or making a lesion in the thalamus. And so again, that's still an experimental study, but it's brought relief to some Parkinsonian patients. Um, and so it's kind of it's with that I want to I'm happy to kind of close my brief presentation of the kind of highlights of their study. The highlights are they found places within motor cortex that are more highly connected to the basal ganglia, the center of degradation for Parkinsonian folks, um, more highly connected, and that's given them better targets to go after, and at least in these experimental treatments of Parkinson's, say through transmagnetic stimulation or guided focused ultrasound, in addition to better targets for deep brain stimulation, which I kind of didn't go over here. I was more excited about kind of the less invasive treatments with magnets and ultrasound. And again, just to repeat myself, I'm very intrigued by the possibility that perhaps the glove is also fitting itself into the scan network rather than going right after the motor neurons connected to your fingers. So I'm curious what you guys might take from this, or if you're. I wonder if your neurologist has, mentioned TMS before or focused ultrasound. Um, I mean, I think beyond drugs, a lot of neurologists are largely just are helping you guys treat symptoms, with Botox and things like this that have, kind of topical effects on muscles, as opposed to neuromodulation of the brain itself by magnets or ultrasound. So,
Steve?
yes,
Yeah, I'm meeting my neurologist on Thursday, so I'll ask him about TMS. I've
gotcha.
I've told him about the gloves, and he's been politely neutral.
Uh-huh, uh-huh, uh-huh. Yeah,
So, but I will raise it with him and see if he knows anything about preliminary studies.
gotcha. Cool. Thanks, Tom. Any other questions or comments?
I just had kind of a thought, so I'm just going to voice it since we're all here.
Yeah,
Um, Dr. Cox and I were talking about kind of networking with neurologists in town, and maybe it would be very helpful if anybody would be willing to give us their neurologist's name and number, just so I know, I'm just trying to know who's around and in town, if possible.
yeah,
Okay.
And you're wanting just local neurologists. Is that
yeah,
right? Okay.
yeah.
Yes. Yes. I would say in New Mexico.
Yeah, Em and I are reading. We're reading a paper, which would maybe um, I can share with you guys sometime as well. But it's I mean, we're here in deeply rural, New Mexico. Um, there, in every state is short on neurologist, and even shorter on movement disorder neurologist. And so there's a model kind of for rural healthcare came out of New Mexico. Um, around hepatitis, in fact, about trying to connect specialists in the big medical centers um, through telemedicine, through kind of sharing information to frontline workers out, away from these big medical centers. So it's expensive and difficult for people to find neurologists to get 3 hours, say, from from northern New Mexico all the way down to Albuquerque. So basically, a structure got built for kind of frontline folks getting new information, and those frontline folks could be nurses, could be at home health workers, or could be local MDs, who didn't have like the latest information about Parkinsonian treatments or assessments, or in fact any disease. This was and this was done largely for hepatitis and pioneered for hepatitis in New Mexico, but it's kind of spread, no pun intended, to other diseases. Um, and a group in Oregon built something called, you know, built a network around Parkinsonian treatment and showed that it was effective, right? And kind of getting better care results in rural Oregon with people connected to the health center. And what we're doing is kind of a rogue version of that, So we are not we're not MDs. We do have a couple of nurses among us, and there has been an MD on occasion. Um, but I think we have the possibility to there is the potential to even kind of add another layer to that network, right? And so if it's just MDs talking to MDs, those MDs are still a little bit too busy or too constrained or not connected well enough to a patient base. And we now have 200 gloves out there. We're connected to a patient base. Um, and and we're sharing information about kind of the care of Parkinson's and the treatment of Parkinson's. And so I would like to bring such a network back to northern New Mexico, and then as a test case, right? And then why this shouldn't be working in other places. So that's a little bit about what Em and I are thinking about. Um, and so it's all about multiplying, right? And so we've got this. If there's, you know, how do you share best practice, right? How do you make it happen? And it's the you guys, I think we all know the medical establishment is very conservative, very slow moving. I don't think I'm not interested in taking risks with people's lives. Um, but looking at you, I feel some urgency in actually, if we've got something that works, how do we share this with other folks? And ideally, by connecting them to maybe not their neurologist but a neurologist. The bulk of Parkinsonian folks do not have a neurologist, right? They're just too disconnected from that luxury. And again, in the richest country in the world, that should not be a luxury. That should be given, but not going to change that. At least I don't know how to change that. But I think I do know how to grow a network of caring, talented people. Right?
Yeah, it's gonna be like potential for like a hub of knowledge sharing,
Yeah.
so
Hmm.
people are more comfortable.
Yeah.
Yeah.
Yeah. What was missing from the New Mexico model, right? It was a kind of doctors talking to doctors, and patient voice was not part of that discussion, right? And so,
Good thinking.
yeah,
Good catch.
we can deliver that. So one direction where we're going. So I've got 10:56. We've rarely gone under 1 hour. I'd be happy to um, set you guys free. We have a beautiful Sunday morning here in northern New Mexico. Um, I'll stick around if people want to chat, but otherwise, I'll see
Well,
you in I'll
Dr.
see you in 2
Steve,
weeks. Hey, Jim.
sorry I was late. I was busy doing something, and then I realized, oh shoot, it's 20 after 10, 20 after 12 my time. Having finished Michael Oken and Ray Dorsey's two books, most recent books, Ending Parkinson's Disease and The Parkinson Plan, I'm going to reread them with a
Hmm.
highlighter in my hand to uh, get with highlight the things that that resonate with me. But I can't recommend those books highly enough. I'm new to this. I just got diagnosed in October.
Hmm.
So I'm uh, like, it's a fire hose of information coming at me as far as the information. I have an appointment with a um, movement disorder specialist in Rochester, New York on May 5th.
Hmm.
So I just got to Dalton, Georgia, where I'm doing a project, and then in the beginning of May, I'm going to go up to northern New York State and
Hmm.
spend the summer there. But yeah, the fact that we have Zoom is a wonderful thing. It's a
Yeah.
silver lining to the whole COVID thing, because
Hmm.
even I learned how to put Zoom on my computer, and a troglodyte like I am is that's a challenge. But if anybody has not read those two books, and I'm now looking at others. Anybody has any suggestions? I'll order them up because I'm wading into this, having no idea. I mean, it started with with a twitch in my right index finger a year ago, October. Well, by this past summer, my whole right hand is doing the jitterbug. Haha, I'm left-handed. Who cares? But I am having trouble sleeping, and I'm
Mhm.
assigning every little problem I have to Parkinson's until otherwise proven, until I can get some answers from
Yeah.
a trained professional. So anyway, that's my piece.
Hey, Jim, would you repeat the names of the books and the authors? I didn't get them written down.
Oh, ending Parkinson's disease. That's a couple of years old, and then just last year is the Parkinson Plan, and you can get them on Amazon, or mine came through Leo's books or and it took forever for him to get it to me, but that was all right.
Yeah.
By Ray Dorsey and Michael Oken, and ending
I'll put them
Parkinson's
both on
disease.
I'll put them both on the website for everybody to
Okay.
see. Yeah, we began this, kind of YouTube series by looking at that first book, Ending Parkinson's, and also, I mean, it's available for free for folks that aren't able to pay for it. So the authors just want to, like, spread the word and give it away. So.
And I've seen Ray Dorsey on a number of podcasts,
Mhm.
and he is passionate about the finding the cause and eliminating the toxins. I
Yeah.
mean, the top three things: diet, exercise, and removing known toxins. Well,
Mhm.
my career is over, and my career involved what I would consider high exposure to various chemicals and solvents, insults they call them. And so now I don't have that, but I have Parkinson's. So I'm, like I say, it's a fire hose of information coming at me.
Yeah.
I'm
Yeah.
new to this. So anyway, that's
Thanks,
that.
Jim. Yeah. And I want to welcome Bridget. It's nice to see you. Uh,
Good evening for me.
so y-
When did
y-
you start? I thought you would start now.
yeah,
Are you
I'm
already?
yeah. So this mountain time, I'm not sure how many hours different we are, 7 or 8 now from Germany. But also, I put 8 new fingers in the mail to you this week.
Okay, fine, fine.
Yeah.
I'm waiting. I wanted to ask you. I'm the
Yeah.
one who broke those many fingers. I don't know why this happened. Is
Yeah.
it, Does it happen to other persons too, or only to me?
I mean, there are, it's, I mean, other people,
Oh,
it's so, I mean, it's not just you. Yeah. We've had to, we haven't replaced everybody's fingers, but some, so either through manufacturing defects or someone like Jim who just swings these things around.
I don't anymore.
Okay.
I've learned my lesson. I gave them the
I,
torture
I, I
test.
and I thought the evening before they broke, I thought, oh, these are very oh, how how do you say in English? Oh, you can do a lot of things with them without them breaking.
Uh-huh.
And
Uh-huh.
then one day after the first finger broke, and then after the next day the second finger broke. I
Gotcha.
don't know.
Yeah.
Yeah, I'm
Yeah.
sorry.
No, don't apologize. No, it's we're still navigating the getting the manufacturing process down. So I apologize for the hassle, but I hope they arrive, this week.
Mhm.
Yeah.
Okay,
So keep
fine.
me keep me posted. Yeah, and we can check the hour difference, right? So we're meeting at 10 a.m. a mountain time, right? Which
Yes,
is
I looked it up in the internet and I thought it was 7 p.m. German time, but apparently
It's
Wait,
daylight
we're on
saving
daylight.
time.
Daylight savings, Bridget.
yes, I know. I counted with this. So it would have been 1 hour earlier. Is it right?
yes, yes, yeah,
Okay,
yeah,
okay, fine.
yeah.
I know it for the next time then.
Okay,
Okay,
gotcha.
fine.
And
Steve?
these are recorded.
Yes, Mary?
Yeah, hi.
Hi.
This is Mary and Rich from California. Do you use the same Zoom link each time, or is
Yeah.
there a new Zoom link
Yes, I use
each
the
time?
same Zoom link each time. I do. Yeah.
Okay, because
Yeah.
I have the Facebook account and my husband, who's using your gloves, doesn't. So
Gotcha.
I'd like him to be able to use this with his own phone. Great,
Sure,
thank you.
sure. Yeah. Okay.
I also have a question, a
Yeah.
mechanical question. Is there any trouble, has anybody had any trouble with taking the gloves on a plane? TSA problems?
That's a
That's a
good
good
point.
question.
Yeah.
That's a good question.
Um, I've not gotten any feedback on that. That's a yeah. I don't. I'm trying to think. I'm
Well, it's a lithium ion battery, which they may have an issue with, but the wires are nothing more than a jumble of wires that you would see with a cell phone cord or charging cords. So they shouldn't,
Yeah,
yeah,
theoretically, they shouldn't, but
and
give it
also
a,
the battery is in the device, so typically that's an issue for mail and for planes, right? If it's in the device,
yeah,
that's acceptable, unless you've got 20 or 30 of them. But
right.
I haven't had a problem with my checked baggage. I've put it in my checked baggage, but not my carry-on.
gotcha, gotcha.
Ah,
Good
Yeah,
to
and they
know.
say that they don't want lithium batteries in the checked baggage because of potential of fire in the
Mhm.
hold.
Yeah.
Yeah, yeah,
No.
Mm.
right.
Okay, well, he'll try on carry on. He's going from California to Tucson, Arizona, to the PWR retreat, which is a physical therapy
Hmm.
approach. And so he wants to take them with him there.
Gotcha, gotcha.
Right. Thank you.
Yeah,
thanks.
keep us
I'm gonna
posted.
be
Yeah.
I'm gonna be flying from northern New York to Raleigh, North Carolina on May 9th. I'll let you know.
Okay, he's
Oh,
going
let us
before
all
that.
know. Let us all know because I have to fly on May 18th for graduation in Georgia. I'm like, whoa, should I take these in my carry-on or check them? I'd
Well,
like to know.
I'll do a test on May 9th
Mhm.
because I'm just going to
uh,
be having carry on. It's just a quick down and back.
Let us know.
I mean,
Thanks.
Thank
there is a
you.
short video on the website about how to swap out batteries. So I did have some trouble getting the gloves with batteries into Italy, and so I began shipping them kind of without the batteries just to see if that would allow things to go through. Eventually, everything went through, so I think it was a kind of slow postal service in Italy. Um, but and then there's a link on the webpage for how to buy extra batteries, and then a small video on how to change batteries. Um, and so,
But
but
they allow laptops and cell phones which
yeah,
have
yeah, I
lithium
agree.
ion
Yes, yes,
batteries.
yeah. And those batteries are infinitely more,
Powerful.
powerful.
Hmm.
And
Hmm.
our batteries do have some electronics attached to them for undercharging and overcharging. But I hate to give you definitive advice because I just don't have data. Yeah.
Is there
It's
is
just
there a
such.
is there a diagram on the website that maybe he could take a picture of and take with him? So if there's any question when he goes through TSA, he could show them what it is.
Um, uh,
Oh my God.
there's
They do look kind of weird. I can see those TSA people going, yeah, a laptop, I know what that is, but what the hell is that?
You just explain it's a therapy for Parkinson's disease and have them just put their finger in a fingertip and say, see, it's a cell phone vibrator, and just to demonstrate what it is. And
Oh, I'm sure they're
you're
gonna.
yeah,
skeptical.
yeah.
This lady's a nut.
Um, So, but as far as a photo, Mary, there is or a diagram. I mean, there's that the video, but there is kind of on the site showing people how to make the glove. There's a photograph of the battery
Okay,
with the
we'll
with
take
this
a picture. We'll
with the
take a
stats.
picture of that then.
Okay,
Great.
okay,
Thank you.
okay.
Thank you.
Good luck. Yeah,
Keep
Thanks.
us posted.
yeah. Um, if there's no more discussion, I'm going to go ahead and turn off the recording. Um, and so I hope I know the time zone thing is a little bit difficult to keep track of data. So when I want to find time zone for some place, I would just type in Santa Fe, Bridget, just say Santa Fe time, and it'll tell you exactly the time it is right now, right? So if you just or we're at the same time as Denver, right? And so rather than so we are GMT. -6 or -7. I forget. You are GMT +1 or 2 or something, or maybe you were just GMT. I'm not sure. We're
But if
Germany.
I know that it started 1 hour earlier, then I came in before today, then I know when I have to
Yeah, yeah, yeah.
yeah.
And
Okay.
and that will stay the same until October when we will
Yes. Yes.
we will fall back.
And then you'll be early.
Then we'll be early. Yes, yes.
Yeah.
Yeah. Okay.
No, I don't think so.
So I'm going to turn off the recording, friends.